So the very first one we're going to do is y equals 1 over x. So just in general today, just to see what these look like, we're doing inverse variation, and that's just y equals some number over x. So a couple different ways this could look depending on what your k value is. I just did a positive 1 for my k value here, so I just did y equals 1 over x. And I just put together a little table here. And so I'm just going to plug these x values in. So like if I do 1 divided by negative 2, right, that's just negative 1/2. If I do 1 divided by negative 1, that's just negative 1. Now, sometimes when we start putting the decimals or putting fractions in, that throws people off. But if you want to think about this, this is 1 over negative 0.5. And I know I've got a negative there, but this would literally be like dividing $1 into 50 cents. That's what's going on there. So that's why when you divide by 1/2, it's the same thing as multiplying by 2. So this is actually going to end up being a bigger number, but it's, or not bigger, it's a smaller number because it's negative, but it's going to be negative 2. If you divide 1 by negative 0.25, it's really dividing by negative 1/4, which would be the same thing as multiplying by negative 4. So that's actually going to be a larger number. Or not, it's smaller because it's negative, but it's going to be a 4. Okay, what if I do 1 divided by 0? Can I do that? No. Okay, now I put this on the table here. This would literally be an error if you tried to type it in your calculator. That's actually, these graphs are going to have some asymptotes, and so that's going to be where the asymptote is at. So we'll do that in 1 second. Now, the rest of these, super easy. They're going to be the same values that we just did here. They're just going to be positive. So I'm going to have 1 divided by positive 0.25, so it's positive 4. Positive 1 divided by positive 1/2, just positive 2. They're the same numbers you just wrote down, just drop the negative. So this would be 1, and this would be 1/2. Okay, now, again, these look kind of weird, and if you use a decimal, just kind of estimate where it would be. So on the graph here, what I would do, so if I go negative 2, negative 1/2, just kind of estimate where the negative 1/2 would be. Negative 1, negative 1, that'll be on a nice point. And then negative 1/2, I would just do your best, go halfway between the 0 and the negative 1, and then we're going to take that down to negative 2. And then negative 1/4, like I just kind of think about that first grid being split up into 4 pieces, so just pretty close to the y-axis, but a little bit over, and we're going to go down to negative 4. And I know that's not a ton of points, but I'm going to kind of connect these up in a second so you can see. These two parts of the graph that we're going to do are actually separate from each other. They're not going to connect. Okay, so if I'm plugging in positive numbers, you're actually going to be up here. So we're going to go over 1/4. So again, real close to the x-axis, up at 4. And then halfway between 0 and 1, you're up at 2. 1/1 is a nice point. And over 2, up 1/2. And you're probably like, what the heck does this do? They don't connect. Okay, so they kind of curve in, and they just kind of hug the x and y axis. It's like a little curve just kind of into that. It's the best I can say. You're just going to get real close to the x and y axis, but not touch it, not go over it. What this is called a branch. And this will be really similar, just going to kind of hug right into the x and y axis, but we're not going to touch it. We're not going to go over it. It's called a branch. Each one of these is going to have 2 branches. And you could plug in more points if you wanted to check, but this is what it's going to look like. And let me label these really quickly. So this branch is in quadrant 1, and this branch is in quadrant 2. Oh my gosh, fired. Sorry, this branch is in quadrant 3. My fault. That's quadrant 3. Bad. All right, if you guys don't know your quadrants, it's kind of weird how they're labeled, but they start in the upper right and they're labeled counterclockwise around there. So quadrant 1 is your upper right, quadrant 2 is your upper left, quadrant 3 is your lower left, and quadrant 4 is your lower right. So these 2 branches are in quadrants 1 and 3. Sorry, I totally said 2 when I was doing that. Now, and that'll happen anytime your k value is positive. That's where the branches will be. Now, what would you guys tell me for the domain here? So like if I'm going left and right, what would you tell me you would write down for the domain? What do you think? Is it all real numbers? What do you think? You don't touch zeros. Okay, now I'm going to show you a little cheat because I'm not going to write that out. I'll show you both. But here's what I do. One of the branches will point left forever, one will point right forever, but you don't touch this, like right in the middle here where this asymptote is. So it's all real numbers, but not zero. Now, if you want to, which you don't have to, the interval notation from that, you would do negative infinity to 0, both in parentheses, and then we'd have to do a little union symbol, and then 0 to infinity. I just find it much easier to write all real numbers and exclude the number you don't want it to be, but you can write it however you like it. And that is going to be your vertical asymptote. So this is just the y-axis, right? But it actually has the equation x equals 0. So your domain is going to be related to your vertical asymptote, which is going to be x equals 0 for this graph. What would you guys write down for the range? Like, how does the graph move up and down? It's the same. So one of the branches goes down forever, one of the branches goes up forever, but we don't touch here in between the branches, which in this graph is going to just be your x-axis, but that has the equation y equals 0. So that's going to be your horizontal asymptote. So your range is going to be all real numbers, but not 0 here, and that's related to your horizontal asymptote, which is y equals 0. It's also the x-axis. So the range is going to be related to your horizontal asymptote. Your domain is going to be related to your vertical asymptote. We're going to talk about that more on the back when we actually shift these around. Okay, does anybody have a question? Okay, so I'm going to have you guys graph this here real quick. The only thing I'm changing is on this one, I have y equals negative 1 over x. So here, my k value is just switching from positive 1 to negative 1. What do you think that's going to do to the graph we just did? How would it affect it if I just changed the top to be negative? It just flips it. Okay, so this will make it really easy to write the table. Okay, we're just going to copy the table that we have, but we're going to switch the pluses and minuses. Okay, so like on the top, you'd have negative 1 divided by negative 2, so this would then be positive 1/2. If you have negative 1 divided by negative 1, it's positive 1. So these values, when you plug in a negative here, they're actually going to be positive because you're going to have a negative divided by a negative, but it's the same numbers we just used. And then 0 is still going to be a problem. You cannot divide by 0. That's going to be your asymptote here. Now, for the rest of these, if I take negative 1 divided by 0.25, I have a negative divided by a positive. So same numbers. These are just going to be negative now, because if I put a negative number on the top, I'm doing a negative divided by a positive. So all those y values, they're the same numbers. They're just going to be negative. All right, so what's going to happen when you do that, the branches are just going to flip over the x-axis to be in different quadrants. So just do your best to estimate. It doesn't have to be perfect, but the quadrants here that you're going to have your branches in are going to end up being in 2 and 4. And that'll happen anytime your k value is negative. They just kind of, same shape, they just kind of hug right into that y-axis there. Same asymptote. Maybe I should use a highlighter here. So x-axis and y-axis, those are my asymptotes. X equals 0 and y equals 0. How would that change the domain and range from the graph we just did? Or what do you think? No, it doesn't. I know they're in different quadrants. All right, this is quadrant 2, this is quadrant 4. That's where my branches will be. Even though they're flipped, you still have one branch that does point to the left forever, one branch that points to the right forever. This branch points up forever, this branch points down forever. So even though they're in different quadrants, you're going to cover everything except where they kind of come together in the middle. So the domain, all real numbers but not 0. The range, same thing, all real numbers, but not 0. These are not shifted. If we shift these graphs, that will affect the domain and range a little bit, but if it's not shifted, it should just be x is not equal to 0, y equals not equal to 0, everything else gets covered. Okay, now I was going to have you guys do this, but actually it'll just take me like 2 seconds. I'm going to graph these on my Desmos up here just so you guys can see, and then here, I'm going to tell you what, I'm going to fail. I'm just going to leave this. Okay, let me just graph it so you guys can see real quick. Okay, so we graphed y equals 1 over x, right? I just wanted you guys to see how it changes the graph if I make that number on the top larger. So if I have 1 on the top, what if I do like y equals 4 over x? So that was that second graph I just put up there. If I did like y equals 8, whoops, let's do over x. Or if I did like y equals, I don't know, 20 over x. So if I take that number on the top and just make it a bigger number, why is this not moving? There we go. You guys can hopefully see, and you can check these out on your own Desmos if you want to. The branches are still similar shape, but what happens as I increase that number, they just kind of pull farther away from the origin. They still have the same domain, same range, same asymptote, everything. The branch is just like a little further out from the origin. They take the same shape, everything else, but you guys can see as I increase that K value, it gets farther and farther away from the origin. So that's the only difference if you change the number on the top. So that's what I'm going to jot down here. As I increase the K value, moves the branches, and I'm going to spell branches correctly, branches away from the origin. So it's just like slightly pulled out is all it is. It's just further pulled out. It's the same shape. It's the same asymptotes, the same domain, same range. Everything else is the same. It's just a little further away. So if you had to compare two of them, like if I had to compare y is 2 over x and 4 over x, the 2 would be just a little closer to the origin. The 4 would be a little further out. That's how you could compare them. And then the k value being negative, let me pull this back up just real quick. All that's going to do, if I just change these to negative, it's just going to flip it to the quadrants 2 and 4. They're still the same distance away from the origin. Whoops, I put a decimal place there. But it literally just flips them. So they're in quadrants 2 and 4. They'd still be spaced out the same way. They're just pulling out from the origin a little bit further as that number on the top is going to get to be a larger number. But they're just in different quadrants. That's the only difference that's going to happen if you change that to a negative. So if the K value is negative, then your branches are in quadrant 2 and quadrant 4. It's the only difference. Same shape, same domain, same range, same asymptote, same everything, just different quadrants. Does anybody have any questions so far? Okay, now the rest of these I'm just going to have you sketch, and I'm going to look for, did you draw the correct asymptotes and are your branches in the correct quadrant? Okay, so this shifting works just like any other shifting we've done all year, I promise you. So because usually we use H and K when I shift stuff around with the X and the Y, because we're doing an inverse variation here, we have K as our constant of variation, so I had to pick different letters for us to use. But with the X, I have a B here as my little example. That's going to shift your graph left or right, and then the opposite way you think. With the X, shifts the graph left or right, opposite way you think. So like if it looks like X minus 5, it actually goes 5 to the right. Or if it looks like X plus 10, it would actually go 10 to the left. Now, anything to the side of the fraction, so totally not part of the fraction, out here, this is plus C, that is going to shift your graph up or down, and that'll just be the way you think. So if it says plus 3, everybody's going up 3. If it says minus 10, everybody's going down 10. Okay, now I'm going to write a little thing to the side here just to help you with domain and range and asymptotes. Okay, so the asymptotes, because each one of these graphs would have 2. The vertical asymptote is going to be x equals whatever the opposite of what is with the x is. So x equals b there. So if it's like a -5, it's going to be x equals 5. If it's +4, it's going to be x equals 4. That's going to be your vertical asymptote. Your horizontal asymptote is y equals whatever number is added to the side of the fraction. Just going to copy that down. So opposite with the x, copy outside, that's going to be your y. And then related to those two things, the domain would be all real numbers, but not whatever that b value is. And the range related to your horizontal asymptote is going to be all real numbers, but not whatever c is. So on the front, it was just 0 for both. On the back, we're going to do some shifting, so we're going to change that. The only thing you really have to pay attention to is what are the asymptotes and what are the quadrants. I'm going to put my branches in, and then we're just going to sketch these. They don't have to be specific points. So on the top, and it really does, like if it was a 4 or if it was a 10 or whatever, it just matters if it's positive or negative. So if I have a +4 and then I have x minus 3 on the bottom, what quadrants would the branches be in? We got a positive number on the top, 1 and 3. Okay, so quadrants 1 and 3. Just, you don't have to write that down. I'm just writing it so I remember it. Okay, what is the x minus 3? How's that going to shift the graph? I have x minus 3. Everyone is awake and paying attention. Yes. 3 to the right. Okay. Here's what I would just have you do. Just grab yourself, like, I don't know if you want to use a highlighter or a pen or whatever. I'm going to redraw the x and y axis based on these asymptotes. Okay, so x minus 3 is going to come over and just literally move my whole y axis over 3 spots. That's my vertical asymptote. That would be x equals 3. Okay, are we shifting the graph up or down here? No, there's nothing added or subtracted. So if there's nothing added or subtracted, I'm not adding anything. So y would just be 0. So we're just going to keep y equals 0. That's just going to keep our x-axis right where it's at. Now, once you got that graph, all you're going to do, we're going to put our branches in quadrants 1 and 3. Now, when I say quadrants 1 and 3, that is based on your asymptotes that you just drew, not on the original graph. When you do the shifting, just kind of make your branches, we're going to make them hug into the asymptote. So just that would be quadrant 1 with my asymptote. This would be quadrant 3. So those quadrants are based on your asymptotes. After you've shifted them, just pretend they're your new x and y axis. That's where you're going to put them. All right, now, domain, super easy. All real numbers, but you're going left and right forever, but you don't touch where they're kind of curving in here together in the center, and that x value should just match your vertical asymptote, which is 3. Same thing for your y's. One branch goes down, one branch goes up forever, but we don't meet here in the middle. So the real numbers, but not in that case 0. So the range should match your y equals asymptote. The domain should match your x equals asymptote. Does anybody have a question? Okay, what am I doing here? Left, right, up, down. I have 4 over x plus 2. Do I move left or right? No, nothing with the x. So x is 0 is actually, and I know this is tricky, but x equals 0 is actually the y-axis. That is x equals 0 right there. All the x coordinates are 0 as you travel up and down. The y coordinates change, but x equals 0. Any vertical line is x equals that number. Okay, am I moving up or down? Up 2, right? I got a plus 2, just copy what you got on the outside. So we're going to take our x-axis and just shift it right on up 2 spots. That is your horizontal asymptote. That is the equation y equals 2. Now, I still got a positive k value in the top, so quadrants 1 and 4, but based on my asymptotes, oh my gosh, 1 and 3. Why am I saying the quadrants wrong today in this class? Okay, 1 and 3 would be your quadrants, and that's all I'm looking for. Domain, just everything, but not your vertical asymptote, so everything but 0. Range, everything but your horizontal asymptote, everybody but 2. Okay. Now, my next one, I got 2 shifts, right? With the x, we're going to do opposite of what it looks like. To me, that looks like a -2, so it's actually going to be +2. So I'm going to draw a nice vertexal line at 2. We're going to shift our y-axis over 2 spots. And then our x-axis, I got that -3, so I'm going down 3, 1, 2, 3. This will be my new X and Y axis. So my problem number here, because we don't want to divide by 0, for X is the 2, and then for the Y, it's going to be the negative 3. Now, everything else, we should be in quadrants 1 and 3 again, because our K value is positive 4 on the top there. Again, you don't have to do specific points. I'm just looking for the general shape and that the branches are in the correct quadrants based on your asymptotes. For your domain, we're just going to say all the real numbers, but not 2. And for the range, all the real numbers, but not negative 3. And then I'm going to do one more. This last one, I do have a K value that is now negative 4. So I'm just paying attention to that. So now I know, just based on that, my branches should be in quadrant 2 and quadrant 4, but based on my asymptotes. This guy, we're going to go X minus 6. So, we're going to go negative 6 would be a problem if I plug that into the denominator. So X is negative 6 would be your asymptote all the way over there. And then plus 1, we're just going to go up 1. Now, the branches are not in the same quadrants as the ones we just practiced with. So quadrant 2 would be here, kind of going off the graph a little bit. Quadrant 4 would be here. Now, everything else is still done the same way because you still have one branch that points left forever, one that points right forever, one that points up forever, one that points down forever, but we don't touch these values here in the middle. So X should be negative 6, Y should be positive 1. Those are the lines that I graphed for my asymptotes. X, everybody but negative 6, and your range, everybody but 1. Okay, is anybody having a question? All right, now on the bottom here, I'm gonna ask you to see if you can write an equation for me. So I'm gonna use, for this first example, y equals 4 over x. If I tell you I'm gonna shift this graph so it has asymptotes at x equals negative 1 and y equals negative 2, how could I write an equation? I'm just gonna keep the y equals and the 4 on the top. How could I manipulate that equation so it would have an asymptote at x equals negative 1 and y equals negative 2? What would that look like? Oh, don't everybody volunteer at once. What would you put in the bottom of the fraction? If I'm going to go x equals negative 1. Yes. All right. And then would I put anything to the side of the fraction? Perfect. That's it. All right. So if it's a negative 1 here, that's going to be the opposite of what it looks like. Just put x plus 1. And if y, whatever y equals, just put that to the side of the fraction. Now, I know I just put a blank graph. We're just going to sketch this here really quick. Okay. So x equals negative 1. I'm just going to make a little mark for myself. So like negative 1 maybe right in here. And then, whoa. Sorry, my thing looked like it was having a seizure there. Okay, and then we're going to go down to, those would be our asymptotes here. Just kind of sketch it. Doesn't have to be perfect. I know I gave you a blank graph. And then the quadrants we would be in based on our asymptotes, since that's positive 4, would just be 1 and 3. Okay, so same question, but different starting equation. If I want to translate y equals negative 4 over x so that it had asymptotes at x equals 0 and y equals 3, so we're going to keep the negative 4 on the top, what would that look like? What would you put in the bottom with the x? So x equals 0, y equals 3. What would you put in the bottom? Not just the x, right? You're not, I mean, if you want to put minus 0 or whatever you can, but it's just be an x. And then the 3, you're just going to write that to the side of the fraction. Just copy that down. So on this one, we would keep, we're not going to move left or right. So we would keep, here, I'll just do it with my lovely little red pen. So we would keep our y-axis where it's at, and then we're going to go up 1, 2, 3. And then here, we'd have to be careful because I had a negative 4 on the top of that. So my branches should be in quadrants 2 and 4 based on my asymptotes there. So it looks something like that, just as a sketch. Okay, is anybody having a question? Okay, sorry, I know I talked for a long time today. So I'm going to let you guys start working on your homework. If you have a